On the first question on similarities and differences between US-Japan tension in the 1980s and US-China tension today, I think there are more differences than similarities. And I think the key difference is that unlike in the 1980s, China and the US are political and military rivals, and that the US is primarily focused on stopping the transfer of semiconductors to China that could have military applications. If you look at the chips that China imports every year, and China spends as much money importing chips as it spends importing oil. It imports chips for phones, for computers, for data centers, for consumer devices, for industrial devices. And there's just one type of chip that has been impacted by the export controls. And these are the types of chips that go in data centers to train artificial intelligence systems. And so 99% of the chips that China bought last year, it can buy this year. There's just 1% that it can't buy. And the US is concerned about these types of chips because if you want to train an advanced AI system, you need to acquire chips that are designed by just a couple of companies, all based in the US, and manufactured by one company based in Taiwan. And these chips are important because the next generation military and intelligence systems will benefit from the application of artificial intelligence. And so the US is trying to stop these chips from being transferred to China, and in doing so to limit China's ability to apply AI to its military. So these restrictions are really laser focused on AI, but the dilemma is that the same chips that can train a car to drive autonomously can also train a drone to fly autonomously. And so there's no differentiating whether the chips are used for military or civilian purposes, which is why these restrictions are different from restrictions on missiles or on tanks or on weapon systems, because they're both military and civilian at the same time. So to make sure that these controls work over the long run, the US controlled not only these chips, but also the tools that are used to make these chips. And the tools that are used to make chips can again be used to make chips for military purposes or chips for civilian purposes. And today there's a small number of companies in the US, Japan, Netherlands that make these tools. And so this will present major problems for Chinese firms, because today all of China's chip-making facilities have foreign chip-making equipment inside of them. The machines that we're talking about, the machines that make chips, are the most complex and precise machines humans have ever made, with hundreds of thousands of components, the ability to manipulate materials at the atomic level. And as a result, these machines will be very difficult for Chinese firms to quickly learn how to replicate. The big change in international politics over the last 20 years has been that China's military capabilities have begun to catch up to America's. And in East Asia, China now has had a vast increase in the number of military systems that it has deployed. And so the US now more than ever has to meet China's quantitative advantages, more ships, more planes, more missiles, with qualitative advantages provided by technology. And so the US is betting that it's going to be able to apply advanced computing capabilities to its military and use that to retain its ability to defend its military position. I think the controls are likely to be fairly effective. The types of machine tools we're talking about are produced by just a tiny number of companies in just 3 countries. And these machines are vast, large, sophisticated machines, so they can't be smuggled. For the chips themselves, they're smaller, so they can be smuggled, but they're only valuable if they're assembled into a vast data center. And data centers, you can't hide. You can see them from space. And so I think, unlike controls of consumer chips, for chips that go into data centers, they're easier to track because they're produced by just a couple of companies and they end up in vast buildings. So I think that efficacy problem is easier than many other types of export controls. In terms of China's response, I think it's correct to note that there's a risk that as controls are tightened on China, China might try to retaliate. Thus far, however, China has not retaliated, and 6 months have passed since the controls. And I think that points to the fact that the Chinese government realizes that decoupling in high technology hurts China more than it hurts other countries, and so China's trying to stop further decoupling from happening. If there were any military escalation in Taiwan or any disruption to trade in and out of Taiwan, TSMC's facilities would stop operating almost immediately. They rely on the importation of materials, component parts, tools from abroad, and so they simply can't operate in a war zone. And if that were to happen, the entire world would face catastrophic difficulties in acquiring semiconductors needed for all sorts of manufacturing. Because today, TSMC produces 90% of the world's most advanced processor chips, as well as the entire island of Taiwan producing 1/3 of the new computing power the world adds each year. So it's not just smartphones and computers and data centers that would face vast delays, it's also dishwashers and automobiles. Today, almost any device with an on-off switch has semiconductors inside, and every year a growing share of those semiconductors, especially at the advanced end, are produced in Taiwan. Well, I think because the military balance has shifted in China's favor, Chinese leaders assess a higher probability today than they would have in the past that they might achieve their goals in a crisis. And my view is that that raises the risks that China's leaders might try to take control of Taiwan via military pressure or via some sort of attack. I think it's a positive thing that Japan is investing more in its semiconductor industry, but I think it will also be challenging for Rapidus, like it's challenging for any new startup in the semiconductor space. At the leading edge, there's very difficult technological challenges, there's very expensive capital investment, and there's the difficulty of finding a market for your services. And I think those are all 3 hurdles that Rapidus will have to prove it can overcome over the next several years. I think there's also, however, a desire in the industry for more sources of advanced production, and the concentration in particular in Taiwan is something that many companies wish they could get diversification from. And so that opens space for companies besides TSMC to try to win market share by offering and emphasizing diversification. It seems to me that the Japanese government has been quite strategic, actually, in this effort to attract TSMC. It's focused on a type of chip making where Japan has a market for specialized image sensors of the type that Sony produces, for example, and it increases investment in a region where Japan has not only many semiconductor companies, but also equipment suppliers and material suppliers. And so it seems to me this has been a facility that is going to play an important role in bolstering new investment in Japan's semiconductor industry. I don't think so. I think that many of the areas where Japan specializes, materials, for example, sometimes machine tools, Japan's capabilities are somewhat unique. And so the fact that the semiconductor supply chain has gotten so specialized means that we needed advances at each part of the supply chain to keep the entire industry moving forward. And so I don't think that from the perspective of Europe, the US, Korea, Japan's investments are seen as a threat. I think one thing that's changed from several decades ago is that today there is no country that has any chance of producing a self-sufficient chip industry. Not China, not the US, not Japan, not Taiwan. And so when we think about a country's position in the industry, countries will have to specialize in a supply chain. And that's what we see today. The Netherlands specializes in lithography, Taiwan specializes in advanced fabrication, the US specializes in design, Japan specializes in materials, and it's only because of specialization that we've had the improvements in technology that have made iPhones and AI possible. And so I don't think we should look at specialization as a bad thing. I think specialization is a good thing. Nor is it the case that specialization is economically problematic. It's often in the semiconductor industry that the companies that make the most money and have the highest profit margins are companies you've never heard of. That's standard throughout the chip industry. And so when I talk to officials in Japan or in Europe or in Korea, you often hear that political leaders say, I want the most advanced factory in my country. And in certain cases that might make sense, but the supply chain is so complex that it's often the case that a country's optimal strategy is going to be to focus on existing strengths, even if they're companies that are not famous, because those companies have unique capabilities and profitable business models. I think in the industry, people will be very surprised, actually. Japan's advantages in materials are seen to be very durable, and they have been for several decades. So yeah, I actually think Japan has a very strong market position in the key segments. But I also think that if you look back at when Japan had largest market share in the late 80s and early 90s, this market share was created via economically unsustainable methods. And at the peak of Japanese market share, there was basically no profitability across all Japanese industry because firms were trying to win market share rather than build profitable niches in the market. And so actually, I think what we've seen is a fairly steady improvement in profitability in the industry because the peak of Japanese market share was not a peak that anyone would like to return to. It looked good on paper, except that none of the companies involved made any money, which is why that for the subsequent several decades, most of them faced really severe restructurings as they tried to change their business models to become more profitable. Well, I think the US government, but also no less importantly, US industry has made clear there's a desire for diversification. And businesses want diversification both because if they have more suppliers, they can negotiate better prices, but also because their boards of directors are asking them to consider worst case scenarios around Taiwan. And that's also what the government is interested in. So that has created an opening for more companies to serve the market for manufacturing high-end logic chips. Intel right now is trying to develop a foundry business, selling high-end logic manufacturing services to multiple companies, which is a response directly to this opening. And I think Rapidus finds itself in a similar position of trying to market its capabilities to that same market opening. So I think there are two separate but related trends in the auto industry. One is electrification. The second is more autonomous driving capabilities. And they're both increasing the number of chips per car, but they're different types of chips. So when it comes to EVs, you need lots of specialized power semiconductors to manage the battery. And these semiconductors are using different types of materials often and produced by different types of companies. Next to that, simultaneously, new cars increasingly have autonomous driving features, which require many new types of sensors and computing as well. And so what you find, for example, if you buy a new Tesla, you have both semiconductors for the battery and a whole suite of semiconductors managing all of the sensors and then bringing all of the data into the primary chip that coordinates the self-driving. And so both these trends are increasing the semiconductor content in a new car. I think I partially agree, but I think that in an iPhone, it's clear what the high-value components are, and they're all imported into China from Japan, from Taiwan, from Korea. In a new car, I think in an EV, we're still learning as these products develop which components will actually be high value in the long run. Will batteries be differentiated or will it be a commodity product? I think we're still not sure. In terms of the assembly process, companies like Foxconn have been struggling to break into the auto industry. And what we've actually seen is that Chinese manufacturers have been rapidly taking market share. Last year, China was the second largest exporter of cars globally, behind only Japan. China is set to overtake Japan in the next couple of years as the largest exporter of autos, predominantly, but not exclusively of EVs. And so I think existing auto firms are completely unprepared for the market challenge posed by Chinese electric vehicle makers. One of the most influential executives in recent years is NVIDIA's CEO Jensen Huang, who led NVIDIA as they created a new type of chip called a GPU, which is a type of chip that's used for AI training. And so if you look at most of the advances in artificial intelligence in recent years, they're AI systems that have been trained on NVIDIA's chip. And so he is someone who over a decade ago looked into the future, saw demand for more AI training, and provided the computing hardware that was necessary to make that possible. I would say Bob Noyce, who was one of the founders of Fairchild Semiconductor, one of the first people to invent an integrated circuit. He was someone who had immense scientific talents, but more important than that was his ability to identify that chips could be sold to a vast market. And he envisioned a product that didn't yet exist, but was able to move the technology to where he wanted the market to be. And that combination of scientific understanding plus business sense has been critical to the chip industry's growth.